Hi everyone. In this video, I'm going to teach you how to expand and condense log expressions by applying the log properties. So at the end of this video, you should really know the log properties inside and out, or at least study them so eventually you do. The first thing you can do with log properties is expand a log expression. Now, when I say expand, here are the directions. You're going to express as a sum or difference of logs. So you start with one log, you're going to end up with multiple logs. That's why it's expanding, because it's making it bigger. In order to do this, you're going to use the log properties, and there are 4 rules in particular that we are going to talk about. One is if you have a product, so if you're taking a log of m times n, you can expand that to be the log of m plus log of n. Or if you're dividing the argument, you can subtract and expand into 2 different logs, so log of m minus log of n. And these are very similar to the exponent rule. So remember, if you had like x squared times x to the third, when you multiply, you add the exponents. Same thing here. When you multiply the argument, you basically add the arguments. So it's kind of like exponent rules, but in log form. When you divided, you subtracted. So if I had like x to the third over x squared, you'd subtract those and get x to the first. Same thing. When you divide, you're going to subtract the logs themselves. Okay, now a rule that's a little bit less familiar is if you have something like log base b of an argument with an exponent. So like if you have like x squared, that argument can come out to the front and become a coefficient, and that is always equal to that exponent times log b of m. That's the power rule. So here's an example. If you have log base 2 of 8 to the x, you can bring this out to become a coefficient, and it's x times log 2 of 8. Okay, the last one I'll talk about in a little bit, but let's just go ahead and apply these so you can see what I'm talking about. So if you have a natural log and you have all this stuff going on or all these operations going on with your argument, okay, the first thing I see here is a big clear division sign. So I know that eventually I'm going to want to apply the quotient rule. So if you're dividing the arguments, you can separate them into their own separate logs and subtract them. So this is really the same as the natural log of the numerator, which is e cubed x to the 5th y to the 6th. Okay, and if we're dividing by the denominator, I can subtract that with its own log, the natural log of a to the 4th. So I've just applied the quotient rule to this example here. Okay, now I want to keep going until I can't use any of these rules anymore. So to expand even further, I can use something called the product rule. So the product rule says if you multiply the arguments, you can break them up into their own logs and add each log with its own argument. So like these are all technically being multiplied. I'm going to go ahead and break that up. So this is the same thing. We're equivalent to the natural log of e to the third plus the natural log of x to the 5th plus the natural log of y to the 6th. And there's nothing being multiplied here. It's just a to the 4th, so I'm going to leave that as it is. And you may even want to put this in parentheses, because sometimes, if you could split something up there, you'd want to make sure all of it was being subtracted, not just part of it. Okay, now I've used the quotient rule, I've used the product rule. What's left is I have some powers. Now, another word for power is an exponent. So I have all these exponents, so I'm going to want to apply the power rule. Anytime you have an exponent on the argument, okay, again, the argument is what you're taking the log of, so like e to the third is the argument of the log. You can bring that out in front of the log and multiply by that as a coefficient. So for example, if I have natural log of e cubed, I can make that as 3 times the natural log of e. So that just jumps out in front there. Okay, this can be 5 times the natural log of x, and this can be 6 times the natural log of y. And our last one will be minus, but minus 4 times the natural log of a. Okay, so I've used all of my rules here. I'm going to try and expand as much as possible. So again, expand at the end, you want it to be longer than it was before, or more logs instead of less. Is there anything else I can do? Well, I don't have any more products. It's just e, just x, just y, just a, so there's probably nothing else I can do. And that would then be my final answer if I wanted to expand using log properties. You can also go the other direction and start with a bunch of logs and condense it back into one log. And with that, I'm going to go backwards from what I did here. So in order to expand this, I first did quotient rule, then product, then exponents. If you want to go the reverse way, I'm going to go in the reverse order. So anything that is a coefficient will first become an exponent. Then anything that's being multiplied or divided will become addition or subtraction. or excuse me, anything that's addition or subtraction will become multiplication or division, so on and so forth. So any coefficient can pop up and become an exponent. So I have two coefficients. I can rewrite those using the power rule. So I'm going from this way to that way. So this is the same thing as log a of x squared minus log a of y, there's no coefficient there, so there's no exponent, plus log a of z to the 1/2. And if you want to be really creative and use a lot of stuff you've learned, you can even write as the square root of z. Okay, now anywhere you see subtraction, that means divide by. Anywhere you see addition, that means multiply. And you can even reorder this if you want. So this is the only thing that's going to be divided, because that's the only thing that's being subtracted. So I could even write this as log a of x squared plus log a of the square root of z minus log a of y. And the reason I reordered it is just because that's the only thing that's being subtracted, so that's the only thing that should be in the denominator or divided by. Okay, now these are being added together, so when you add, as long as they have the same argument, you can rewrite that as one log. Now if this was a log b and a log a, I couldn't combine those because then you'd be taking two different logs, so they're not like terms. If they are the same argument, I can make this log a of x squared times the square root of z. So you can go back and forth. When you multiply, you add. When you add, you multiply. And I'll take this one step at a time and leave this the same. Okay, so now anything being subtracted, you can rewrite as division. So this is being subtracted. This is what has to be in the denominator then. So this is the same thing as log of a of x squared times the square root of z over y. And now you've condensed it, which means to write with one log. Condense means to get smaller, so that makes sense. Again, you can only do these rules if they have the same base, which I should have mentioned before. So these all have a base of b, so you can apply the rule. If they don't have the same base, you can't combine them because they're different logs. They're taking different things. And if you want to look at more examples, here's more examples of how you can apply those rules. Okay, the only rule I didn't talk about on this side is the equality rule. Essentially, it says if you have log of the same log of an argument and they're equal, then the arguments have to be equal. So like if I have log 8 of 3x minus 4 equals log 8 of 5x plus 2, if you look at this, it makes sense. So they already have the log 8 the same. So in order for these expressions over here to be the exact same thing, whatever's right here would have to be equal. And we'll look at more examples of these when we get into solving, but I thought I'd preview that now. Okay, the last rule may be helpful if you are using a calculator. But it's another log property that you can use, but again, it's most helpful for calculating stuff because your calculators don't necessarily have a button that says log base 3. If you plug it in your calculator, it'll just say log, which again is log base 10. So how would I plug in something in my calculator that says log base 3? And the answer is using this change of base formula, which is another property of logs. So what the change of base formula says is essentially if you have log base c of u, you can rewrite that as some log of u over some log of c. So it can be log with base of b, it can be log base 10, it can be natural log. It doesn't matter what the base is, as long as the base is the same. Then you can just take the log of the argument divided by the log of the base. So this is the argument, this is the base. Let me show you how that would work. Okay, this formula says I can take some log, so maybe I'll do log base b of the argument, which is 17, divided by log same base of the base of the original base, I should say. So these two things are equivalent. And I can do this with any base b. So I could even make my base 10. So if I change this to base 10, well, we can just write that as log of 17 divided by log of 3. Okay? And again, I can do this with any base, so I can even do this with base of e. So I could write this as natural log of 17 over natural log of 3. Okay, now let's say the base wasn't b originally. Let's say it was a number, and I'm going to pick any number I want because it doesn't matter. So let's say I pick 3. If you plug in the blue, the green, and the red in your calculator and get a decimal, they're all going to give you the exact same thing because they're all equivalent. And that's what the change of base formula says. But the reason we are going to use it is because I can't plug this into my calculator unless I have a really nice fancy calculator, but I can plug in this or this because there's a natural log button and a common log button. So we'll talk about this a little bit more. That's just how you use the properties in the formulas. It's not necessarily where they come from or why, but if I ask you to expand, condense, or calculate a log, you should know how to do that by the end of this video. Have a great night.